Hi, this is Mrs. Jackson, and this is Chapter 1, Section 1, Part 4. In this video, we're going to be describing intervals of functions mathematically. All right, so for the first question is what exactly is an interval? The word interval is something that we use to describe a portion of the function graph. If we need to communicate with each other on talking about a piece of the graph, we call that an interval. And when we discuss things in math, we tend to use mathematician shorthand with symbols in order to describe things and make meaning with things. So there's actually two different styles of notation for intervals. The textbook uses both of those throughout, and so we need to be able to write and read both styles. So the first style is called set builder notation. And set in this case means a set of numbers. And in math, the symbol that we use to indicate set is these squiggly things here. They're called braces. And so whenever you see those braces in a statement in math, that means set. The next thing we're going to write down inside the braces is what variable we're talking about, either x or y. Almost always it will be x, but when we're talking about the range, it's going to be y. And then finally, we would follow by an inequality statement. So, for example, we could say the set of all values of x such that, and this vertical straight line translates to such that, the set of all values of x such that x is greater than or equal to 2, for example. That could be a set builder notation for a particular interval. The second style is called just interval notation. And interval notation is shorter. So interval notation uses two numbers. So you're going to have a number, comma, number. And that first number here is the minimum in the interval, and the second number is going to be the maximum. And we're going to surround those numbers with either parentheses or I should say, a combination of brackets. So the parentheses are meant to indicate open, and a bracket is meant to indicate closed. And recall that, I forgot an S here. Recall that open means not equal to, and closed means equal to. So if I were to write this same example here that I wrote in set builder, if I were to write that in interval notation, I would go with my minimum number here. My minimum number is 2, and I wrote greater than or equal to 2, so I've got 2 as my min, and it is equal to, so I'm going to use a bracket. And this is non-terminating, so it's going all the way up to positive infinity as my maximum. And infinity is not a number that you can touch. It just keeps growing. And so we would indicate that as open because you can't actually terminate at infinity. So this would be our min, and that's our max. Okay, so I have a list of 5 examples here that we could go through. We've got a verbal expression here in English. We're going to translate that into symbolic notation, either set or interval. So the first example is all real numbers. Well, all real numbers would go from negative infinity all the way up to positive infinity. We have to agree on what kind of variable we're talking about. And just for illustration purposes, let's use x's for the whole list here. So all real numbers, the set of. So we would say the set of, with our braces, x such that, and we can write in English all real numbers if we wanted to, and you will definitely see that in the textbook. Another way to write that would be x such that x is less than positive infinity and greater than negative infinity. Close your set. If we were to write that in interval notation, our minimum is negative infinity, our max is positive infinity. You cannot touch either, and so we would go open symbols with the parentheses. Next example, we have all real numbers greater than or equal to 10 and less than 25. When you see that word and, you know you're talking about a conjunction. So we've got x values less than 25 and greater than or equal to 10. So we're going to have the set of all x values such that x is less than 25 or greater than or equal to 10. And in interval notation, our minimum is 10, our maximum is 25. We can be equal to 10, so we're going to close that with a bracket, and we are less than 25 but not equal to 25, so that would use a parentheses. Next example, all real numbers greater than negative 7, so we have all values of x such that x is greater than negative 7. Close our set. And in interval notation, negative 7 is our min. It is non-terminating, so our maximum would be infinity. We are not or equal to negative 7, so that's going to be an open, and infinity is an open. All real numbers greater than negative 20 and less than 5, we have another compound. So we have the set of x values such that x is less than 5 and greater than negative 20. Close the set. In interval notation, our minimum is negative 20, our maximum is 5, and both are open. Last example, all real numbers less than or equal to 5. So we have the set of x values such that x is less than or equal to 5. This is non-terminating. And in interval notation, our minimum then would be negative infinity. Our maximum is positive 5. At negative infinity, we'd be open. We can be equal to 5, so we're going to close that with a bracket. So the last point I want to make here before closing the video is that this notation looks an awful lot like a point, where that would be x and this is y. But when we're talking about intervals, we're using the same type of notation to have a different meaning entirely. So in interval notation, this is your minimum and this is your maximum. So try to not be confused by the same style of notation to mean different points. Okay, let's just finally write that this is an open, not equal to, and a bracket is closed. And that does mean equal to. All right, that's how we describe intervals of functions mathematically in two different styles of notation.